Okay, everybody, another trig substitution example. So again, you'll see our chart with the different forms that we look for and the suggested substitutions. So let's just jump in. So I'm looking at the antiderivative of the square root of x squared minus 4 divided by x. And so this one looks like our third form here, because we've got this x squared minus 4 or x squared minus 2 squared. So this suggests that we try the substitution x equals a secant theta. In this case, a is 2, so we'll try x is equal to 2 secant theta, which gives us that dx is going to be equal to 2 secant theta tangent theta. Okay? So this integral will become x squared is going to become 4 secant squared theta minus 4 over x, which is 2 secant theta, and our dx becomes 2 secant theta tangent theta. So right off the bat, I see that these factors of 2 secant theta can cancel. Let's keep going. I can factor a 4 out of the secant squared theta and the minus 4 and pull that outside of the square root as a 2. And I'll be left with, oops, let me kill the denominator. So let's just go ahead and the 2 will come out. And we're left with secant squared theta minus 1. And we've got our tangent theta d theta. All right, so secant squared theta minus 1, we notice is the identity, is equal to tangent squared theta from this suggested identity. So this becomes tangent squared theta tangent theta d theta. Let's pull the 2 out front. Tangent squared theta, the square root of it is going to be tangent theta. But we've got another factor of tangent theta already, so this becomes tangent squared theta. Now here's a little fun part. We're going to go back and use the secant again. This identity that secant squared theta minus 1 is equal to tangent squared theta, so this tangent squared theta becomes secant squared theta minus 1 d theta. And now we just need to remember the antiderivative of secant squared theta is tangent theta. And the antiderivative of 1 is just theta, in this case, plus c. All right, so we've gotten out of our integral, our antiderivative, but we still need to replace these thetas with x's somehow. So we're going to use our original substitution. So notice, for instance, that tangent theta is equal to the square root of 1 minus secant squared theta, right? I'm just taking the square root of this antiderivative, this identity up here. And that we already know that what secant is, secant, looking at our first substitution, secant of theta is just x over 2. So we'll have 1 minus x squared over 4, right? Squaring x over 2 gives us x squared over 4. I can rewrite this as 1/2 4 minus x squared if I want to, right? I like to do this. Again, notice now I'm back to the form that was written right here. This is exact, 1/2 4 minus x squared is the same thing as the square root of 1 minus x squared over 4. You can work through the algebra to see that it's correct. There's nothing wrong with how I had it written the first time. I just like to get it back to how it looked, the form that it started with in the integral. Something about that seems pleasing to me. All right, also we've got a theta by itself. So now let's take this identity, or this substitution. We had x equals 2 secant theta, or x over 2 is secant theta, which means we can write theta as inverse secant of x over 2. We can also write this as cosine inverse of 2 over x, right? That's just the relationship between secant and cosine. So either one of these is fine. I prefer the cosine inverse one. There is no good reason for that. Just for whatever reason, I like to have my sort of, I don't know, the primary trig functions and inverse functions there. Okay, so now I'm just putting all of this back in. Tangent theta becomes 1/2 4 minus x squared minus cosine inverse 2 over x plus c. Maybe we want to distribute that too. We'll have 4 minus x squared minus 2 cosine inverse 2 over x plus c. Either way is fine. So you'll notice along the way there were plenty of choices I made. I did not need to take this step here. I didn't need to write it this way. That's a little bit of personal preference. So none of those would have been wrong. It's just how I'm preferring to write it with no good motivation other than something in my soul feels better when they're written that way. Okay, that's it for this one. Thanks, everybody. I will see you next time.